In the next 9 minutes, we are going to show you the birth of the universe. Are you ready? Let's go! At first, there was nothing. No space, no matter, not even time. Then, 13.8 billion years ago, everything began. The Big Bang. The universe started expanding faster than light itself. It was unimaginably hot and dense. Tiny particles called quarks and electrons collided at unimaginable speeds. Within fractions of a second, those elementary particles combined to form protons and neutrons. And within just 3 minutes, these particles came together to form the first atomic nuclei, mostly of hydrogen and helium. At this stage, the universe had already expanded 1 million times and was cooling rapidly. As the universe continued to expand and cool, more particles combined to form the first atoms, mostly hydrogen and helium. Protons and neutrons were flying everywhere. And it was until about 380,000 years after the Big Bang that the universe had cooled enough for electrons to be captured by these nuclei. Once the electrons were attached, the resulting hydrogen atoms could then start existing in their most stable form, allowing light to travel freely for the first time. Before this moment, light couldn't pass through the fog of particles that pervaded the universe. But now light was free. And as it bounced off the abundant hydrogen atoms, the entire universe glowed with an eerie red light. This faint glow still exists today, and we can see it as the cosmic microwave background radiation, a snapshot of the universe as it was 380,000 years after the Big Bang. But what happened before that? Well, that's a question scientists are still trying to answer. What we do know is that the period following the Big Bang was a time of tremendous change. As the universe continued to expand and cool, gravity caused clouds of gas to come together. In some places, these clouds of gas became so dense that they ignited into the first stars. These stars were giant balls of burning hydrogen and helium. Their cores reached temperatures of over 10 million degrees Celsius. And under such extreme conditions, something incredible happened. Hydrogen and helium fused together to form the first heavier elements, including carbon and oxygen. For billions of years, these stars dominated the universe. But they were eventually, they ran out of fuel and collapsed under their own gravity. In their final moments, they exploded in spectacular fashion, scattering the elements they had forged across the cosmos. These explosions are called supernova. They played a critical role in the formation of heavier elements, including iron and gold. As these explosions occurred again and again, the universe became enriched with a variety of elements. Over millions of years, gravity pulled these elements together to form new clouds of gas and dust. Some of these clouds were large enough to collapse and ignite, giving birth to the first galaxies. Galaxies are vast cities of stars held together by gravity. Our sun is just one of about 100 billion stars in the Milky Way galaxy. Each galaxy is a unique island of stars, gas, and dust. They come in a wide variety of shapes and sizes, from giant spirals like the Milky Way to smaller ellipticals and most galaxies contain hundreds of trillions of stars and stretch for hundreds of thousands of light years. That's really big. Our journey through the universe has taken us from the Big Bang to the birth of the first stars to the formation of galaxies. It's been a lot to take in, but we've only just begun. In the next episodes, we'll explore the birth of our solar system, how Earth became a unique planet capable of supporting life. And we'll continue to uncover the mysteries of the universe. The formation of the solar system began about 4.6 billion years ago, when a giant cloud of gas and dust collapsed under the force of gravity. As the cloud collapsed, it formed a spinning disk around a central ball of hot plasma. The spinning disk would eventually become the asteroid belt between Mars and Jupiter. The material in the cloud was not evenly distributed under the influence of gravity. Denser regions formed, which then attracted more and more material. Slowly, planets began to take shape. Closer to the sun, where temperatures were higher, heavier elements could exist, forming rocky planets like Mercury, Venus, Earth, and Mars. Further out, where temperatures were cooler, lighter elements could exist, forming gas giants like Jupiter, Saturn, Neptune, and Uranus. Between the inner and outer planets lies the asteroid belt, a region of rocky leftovers from the early solar system. Comets and icy Kuiper belt objects also populate the outer reaches of the solar system. Earth formed about 4.54 billion years ago, not far from where it is today. Its early atmosphere was very different from today's. It lacked free oxygen and was full of volcanic gases. But over time, the atmosphere changed as life evolved. Photosynthetic organisms released oxygen into the atmosphere, eventually making it suitable for aerobic life. The solar system has remained relatively stable for billions of years, but it's not entirely static. Objects in the solar system move in elliptical orbits, and gravitational perturbations from objects like Jupiter and Neptune have knocked some asteroids into Earth's path. These impacts have left scars on the lunar surface and delivered water and organic molecules to Earth. As we continue to explore our solar system, we learn more about its dynamic history. From the rings of Saturn to the icy plains of Pluto, each object has a unique story to tell. We have seen the birth of the universe, the formation of galaxies, and the birth of our solar system. Now we will witness the birth of Earth. About 4.5 billion years ago, Earth was a hot, molten mass of rock. As it cooled, a solid crust formed, which was bombarded by asteroids and comets. Over time, Earth's atmosphere began to form as gases from the mantle and crust were released. Early Earth was a very different place from the one we live on today. It was hot, humid, and full of volcanoes. The first oceans formed as water vapor in the atmosphere condensed and fell to the surface. These oceans were rich in dissolved gases and minerals. Life on Earth began in these early oceans. The first organisms were single-celled bacteria. They used photosynthesis to convert sunlight into energy. This process also released oxygen into the atmosphere. As oxygen levels increased, the atmosphere began to resemble today's composition. Earth's early atmosphere was gradually replaced by an oxygen-rich one that allowed for the evolution of more complex life forms. Earth has experienced major climate shifts throughout its history. In the Hadean Eon, Earth was hot and volcanic with no ice at the poles. During the Archean, the first continents formed, and the atmosphere became oxygen-rich. The Proterozoic era saw the formation of supercontinents and the first ice ages. The Phanerozoic Eon, which began about 540 million years ago, is divided into three eras: the Paleozoic, Mesozoic, and Cenozoic. During the Paleozoic, fish, amphibians, reptiles, and insects appeared. The Mesozoic, or Age of Reptiles, saw the rise of dinosaurs. Finally, the Cenozoic era, or Age of Mammals, began with the extinction of the dinosaurs and continues to this day. Earth has been shaped by a variety of forces, both internal and external. Plate tectonics. The theory that Earth's outer layer consists of moving plates that interact with each other has played a major role in shaping Earth's features. Volcanoes and mountains have been created as plates have collided, diverged, and slid past each other. Earthquakes occur when plates suddenly shift, releasing energy in the form of seismic waves. Earth's atmosphere has also been shaped by life. Plants, oceans, and living things have altered the composition of the atmosphere over time. The current atmosphere is a delicate balance of gases that make life possible. Earth is truly a remarkable planet. With its diverse array of life forms and dynamic geology, it is a unique oasis in the vast expanse of space. The Earth is the only planet we know of that supports life, and it is the result of billions of years of geological and biological processes. The conditions that make Earth habitable are the result of a delicate balance of factors, including its distance from the sun, its atmosphere, and its abundance of water. These factors have allowed Earth to support a wide variety of life, from single-celled organisms to humans. What happens next? Will humanity spread throughout the galaxy or die out? It's up to you to write the next chapter of the story. So don't forget to leave your comments below and let us know what you think. Thank you for joining us on this incredible journey through the birth of the universe. We hope you learned something new and were inspired by the wonders of our vast universe. Don't forget to subscribe for more updates on all things space. And if you enjoyed this video, please give it a thumbs up. Your support means the world to us and helps us continue producing quality content. Thanks for watching! We'll see you next time.